Hi everyone, welcome to our discussion. In this video, I will be discussing about the topic measures of central tendency and dispersion. So I think you are already familiar with this topic or you've heard of this topic before because you might probably discuss these topics when you were either in senior high school or junior high school. So let's proceed with the definition. So by definition, a central tendency or measure of central tendency is a central or typical value for a probability distribution. It may also be referred to as center or location of the distribution. The term central tendency refers to the middle or perhaps the typical value of the data and is measured using the mean, median, and mode. So in other words, the measures of central tendency lets us know what is the average or what is typical for a set of data. And I think you've already heard these terms, these words before: the mean, the median, and the mode. So these are the three measures of central tendency, which I will be discussing one by one. Let's start off with the mean. So the mean is the widely used measure of central tendency. This is also the most stable measure of central tendency because all the data in the data set are being considered. It is referred to as the average. So I think you're familiar of that term or of that word average of the numbers in a given set of data. In order to calculate for the mean, just get the sum, take note, get the sum of the numbers and divide it by the total number of numbers in the data set. So the mean is denoted by the symbol, this one, and that is read as X bar. So again, to get the mean, simply add all the numbers in the data set and then divide it by as to how many numbers there are. Let's have an example. I'm sorry. Yeah. Let me show you the formula first. So the formula for finding the mean is again X bar is equal to the summation of all X over N. So this symbol right here, the sigma, it's a Greek letter. So that is read as the summation. So to get the summation, you simply just have to add all the numbers, all the values in a given set of data. Take note, X is the value of an observation and N is the total number of observation. So again, that's X bar is equal to the summation of X over N. So here we have an example. Find the mean of the set of values 3, 4, 6, 8, 9, and 5. So we have here the formula. So what we have to do is simply to add all the numbers in the given set of data. That's 3 plus 4 plus 6 plus 8 plus 9 plus 5. And since there are 1, 2, 3, 4, 5, 6 numbers in our data set, so our N is 6. So adding all the numbers, we get 35. 35 divided by 6, that is 5.83 or approximately 5.83. Now, in order for us to have uniformity in your answers, so as much as possible, round your answers to 2 decimal places. Okay. So, so much for the mean. We have here the median. So the median is the value separating the higher half of a data sample, a population, or a probability distribution from the lower half, meaning we will be dividing the data set into two groups, the lower half and the upper half, and the number in the middle, that will be our median. So for a data set, it may be thought of as the middle value. It is denoted by the symbol MD. So I think that's easy to recall because median, MD. So we have here two examples. Let's have the first one. So in the data set 1, 3, 3, 6, 7, 8, and 9, the median is 6. So how did we arrive with the answer 6? First thing that you have to do in getting the median is to arrange your data or the data set either from highest to lowest or lowest to highest, ascending or descending order, whichever is okay, as long as the numbers are being arranged. Now, try to count as to how many numbers there are. So there are 1, 2, 3, 4, 5, 6, 7. So if the data set contains an odd number of data set, so since n is 7, there are 7 numbers, it's easy to get the median. Since we have 3 numbers for our lower half and 3 numbers from our upper half. So it will follow that 6 is the middlemost number. Therefore, that is our median. So again, that's how we get the median if the data set is odd. How about if the data set is even? So let's have the second example. In the data set 2, 4, 7, 8, 9, 12. So there are 1, 2, 3, 4, 5, 6 numbers in our data set, and 6 is even. So so this is our lower half, that's 2 and 4. This is our upper half, that's 9 and 12. And we consider or take the 2 middlemost numbers, that's 7 and 8. Add those numbers, then divide it by 2. So here, our median is 7 plus 8. That is 15 divided by 2. That is 7.5. So it's actually easier to get the median if the data set is odd, since that can easily be located. But if the data set is even, same as the second example, so you get the 2 middlemost numbers, then add and divide it by 2. I think that's easy to understand. Next, third one is the mode. The mode of a set of data values is the value that appears most frequent. The mode is the most commonly occurring value in the distribution. Mode may exist sometimes, and sometimes it does not. If it exists, sometimes it has one mode, or sometimes it has more than one mode. So the mode is denoted by MO. So again, the mode is the number that is mostly occurring, or the number that is repeating. There are times that there is no mode if there are no numbers that are repeating. Sometimes also there can be one mode, there can be 2, there can be 3, there can be 4, and so on. So if there's only one, if there's no mode, simply answer no mode. If there is one mode, that is called unimodal. If there are 2, that's bimodal. If there are 3, that's trimodal. If there are 4 or more, that is multimodal. So let's have an example. So given the data set 3, 2, 7, 3, 4, 5. So mode is 3. Since 3 is repeated, there are 2 number 3s. In this case, since there's only one mode, so that is unimodal, and our mode is 3. Okay? Second example, given the data set 4, 5, 3, 4, 4, 7, 5, 6, 3, 8. By the way, for median, you need to arrange the data set. But for mode, there's no need for us to arrange a set of data. So here for our second example, the modes are 4, 5, and 3. Why? Because there are 2 4s, there are 2 3s, and there are 2 5. So these are the numbers that are repeated. So more than the other time. So for this case, that is trimodal. And our modes are 3, 4, and 5. So again, that's the mean, which is simply the average. Add all the numbers together, divide it by as to how many numbers there are. The median, the middlemost number, and the mode is the number that is reoccurring or being repeated. Now let's proceed to the measures of dispersion. So the mean, median, and mode, those are measures of central tendency. Now we have measures of dispersion. So the terms variability, spread, and dispersion are synonyms, meaning they have the same meaning. They refer to how spread out a distribution is, so how far the data set are from each other. Measures of dispersion tell us how much the data tend to disperse or scatter. So one measure of dispersion is what we call as the range. So measures of dispersion are the range, the variance, and the standard deviation. So again, it is a measure of how far the scores or the data or the values are from each other. So we have the first one, the range. This is the easiest easiest measure of dispersion. It's easy to solve, easy to find. So the range for a set of data is found by subtracting the smallest value from the largest value in the given set of data. So you simply have to locate the highest value, then subtract it by the lowest value. So formula for the range is highest number minus the lowest number. So for example, the grades of 10 students are shown below. The respective range for male and for female students is also shown in the table. So note that the mean is 85. So the mean has already been solved for us. If we add the data for the female, the mean is 85. And also for the male, the mean is 85. But since we are looking for the range, so for the female, the highest grade is 88 minus the lowest grade, which is 82. Therefore, the range is 6. Now for the the male students, the highest grade is 97 minus the lowest grade, that's 70. Therefore, the range is 27. Now, what does this mean? It means that the grades of the male students are farther from each other compared to the grades of the female students, which is actually clear or can be seen based on the given table. Next, we have what we call as the variance. So the two commonly used measures of variation that consider all scores in a given set of data are variance and standard deviation. So earlier for the range, it does not consider all the data sets since we are only after the highest and the lowest score. But for variance and standard deviation, which are related to each other, all the scores or all the data in the data set are being considered. So let us again consider the grades of the students shown below. Still the same table. So study the table below. You may tell to yourself that you are familiar with the procedure since again we have discussed this one before in your junior high school or senior high school topics. So anyway, this is how we are going to get the variance. So we have here again the grades of the female students. So that's 82, 83, 85, 87, and 88. So the first thing that we have to do is to solve for the difference of the mean from the individual scores or grade. So the mean was already given earlier. But if you want to solve, so that is 10, that's 15, that's 5, that's 2, that's 425. Then dividing it by as to how many grades there are. So there are 5. It's 8, it's 25. So here our mean is 85. So x bar is 85. Now again, the first step is to subtract each individual score by the mean. So that is 82. Here we have 82 minus 85. Next, 83 minus 85. Then 85 minus 85. Then 87 minus 85. Then 88 minus 85. So we have here the differences of the individual score subtracted by the mean. Next is to square the difference of the mean from the score. So whatever number that we obtained here by subtracting the score from the mean, you just have to square it. So that's negative 3 squared, that's 9. Negative 2 squared, that's 4. 0 squared is 0. 2 squared is 4. 3 squared is 9. So if we say square, simply multiply the number by itself. So negative 3 times negative 3, negative 2 times negative 2, and so on. Third step is to to find the sum of the squares of the difference of the mean from the score. So simply add all the answers that we got here. So that's 9 plus 4 plus 0 plus 4 plus 9. Therefore, that is 26. But we are not done yet. So we now divide the sum of the squares, the score that we got earlier, or the answer that we got earlier, of the difference of the mean, the deviation from the mean, from the score with the number of scores in the given data set. So this is the answer that we got earlier, then simply divide it by as to how many data there are. Since there are 5, so that's 26 divided by 5, that is 5.2. So that is the variance of the grades of the female students. So that's 5.2. Now let's try to consider the variance, or let's solve for the variance of the scores of the 5 male students. So this is the formula, by the way. That's the summation of the quantity of x sub I minus x bar squared. I is from 1 to n. So these are the grades of the male students: 70, 82, 86, 90, 97. Subtract each individual score or grade by the mean. So 70 minus 85, 82 minus 85, 86 minus 85, 90 minus 85, 97 minus 85. Then after subtracting, square each quantity. Same with what we did earlier. And after that, add all the scores together. It's 404. Then divide it by as to how many data there are. There are 5. Therefore, the variance is 80.8. So if we try to compare, for the female students, the variance is 5.2. For the male students, the variance is 80.8, meaning the scores or the grades of the male students are more varied or more dispersed or far away from each other compared to the grades of the female students. So these are the steps to compute for the variance of a given data set. We must perform these steps, which that was what we did earlier. Number 1, determine the mean for the given set of data. So earlier, the mean was already given, but if it's not given, so you need to solve for the mean, and to solve for the mean again, simply add all the scores or the data together, divide it by as to how many data there are. Number 2, determine the deviation from the mean for each value in the data set. So deviation meaning subtracting each individual score by the mean. So after getting those values, you have to square each deviation. So whatever answer you got from subtracting, square it. Then step number 4, compute the mean of the squared deviation. So after squaring each deviation, add all the scores together, then divide it by as to how many data or number or values there are. So that was variance. Now we have standard deviation. And as I've told you earlier, the variance and the standard deviation are related to each other. If you already have the variance, it's very easy to get the standard deviation. If you have the standard deviation, you can also solve for the variance. So the standard deviation formula is obtained by simply getting the square root of the variance. So in summation notation, the formula for the standard deviation in population is given by the parameter, this one. So if you can observe, this is our formula for the variance. Now to get the standard deviation, simply get the square root. This is the symbol for standard deviation. So let us again consider the grades of the 10 students below. So from the previous section, the variance for the 5 female students scores 5.2. Hence, the standard deviation for the 5 female students score is the square root of 5.2, which is approximately 2.28. So you can try to check that one out in your calculators. Try to solve, get the square root of the variance. So the variance of the scores of the 5 male students is 80.8, which we have solved earlier. Thus, the standard deviation is the square root of 80.8, which is approximately 8.99. Again, you can try to double check that one. So we can say as a conclusion that the scores of the 5 male students is really more spread out than the scores of the 5 female students, since standard deviation for the female is 2.28, standard deviation for the male students is 8.99. So the larger the variance, the larger the standard deviation. That means that the scores or data are more far from each other, or more dispersed, or more varied. The lesser the variance and the standard deviation, meaning the closer the data set are to each other. So yeah, that's the end of this discussion. If you have questions, if you have clarifications, feel free to comment your questions on the comment section below. You can also ask your questions in our group chat. So thank you so much for your time. Thank you so much for listening. You take care always. Bye-bye for now.